Okay, so in this assignment we're going to practice writing functions instead of in words, in symbols. So the way you can do that is you can imagine putting a variable in. You can choose any letter you want, but it's common to use x. So I imagine what would happen if I put x into the aim function. Well, I see what would happen is that it would double, it would get multiplied by 2. So I can write x times 2, which you usually write as 2x in algebra. And then the next thing that happens is that you add 1, so plus 1. So that's how I can write the aim function in symbolic notation. So I could have either written the aim function like this with words, or I could have written it like this. Okay, let's try the inverse aim function. And another shortcut is instead of having to write the word inverse, you can just write the function with a tiny little -1 up in the air above it. And it looks like an exponent, but it's not an exponent. Exponents are for numbers, not for functions. So that's how we remember that -1 is not an exponent. It just means inverse function. I'll go ahead and use the same letter, but you can use whatever letter you want. I'm going to use x. And in the inverse function, what I do is I subtract by 1 and then divide by 2. So I'm first going to take whatever letter goes in this case I chose x, and I'm going to subtract 1, and then I'm going to take that number, this whole number here that I get from doing x minus 1, and I'm going to divide that by 2. So the way I show that is I divide this whole thing by 2. So that's how you do the symbolic notation for both the aim function and the inverse aim function. Alright, on to the JOP function. So let's figure out. So JOP of x is equal to, so it looks like I'm going to do plus 3, so I'll do x plus 3, and then multiply by 6. And I might be tempted to just write times 6 like this, but you'll remember that if I write times 6 like this, then it's only going to multiply times the 3. But I want to multiply this whole number that I got from adding 3 times 6. So the way you do that is with parentheses. So I'll put parentheses around it like this. So I'm first going to do x plus 3, and then I'm going to multiply by 6. Now let's do the inverse JOP function. This tiny little -1 up here that means inverse function. And it looks like first I'm going to divide by 6, so let me show dividing by 6, and then after I get that number I'm going to subtract 3. Alright. Next one is the kix function, and this one is kind of hard to write mathematically. So, but one way that mathematicians do it is they'll say kix function, and then let's say we'll choose letter x again, and they'll say, since there are two possibilities, they will say, they'll do this kind of curly brace like that, and they'll say the answer can either be 0 or 1, and then it's going to be 0 if x is odd, if x is even, and it's going to be 1 if x is odd. So you might see that sometimes in math books. Mathematicians like to write their function like that. Or in this case, it's probably just faster to write it in words, because you had to write a bunch of words anyway, so either way you want to do it. Alright, on to the BP function. So the BP function, let's do a different letter this time. Let's put a Y in this time. Doesn't matter. And let's see what's going to happen to it. So the first thing we're going to do is subtract 1. Then we're going to multiply by 2. Remember, we want to multiply this whole thing by 2, so I'll use parentheses. And then I want to add 3 to whatever I get. So there's the BP function. The inverse BP function is going to be subtract 3. So I'll do y minus 3. Divide by 2, so I want to take that whole number that I get from doing y minus 3 and divide that by 2. And then I want to do plus 1 to whatever that result is. Alright, next thing, the SVDI function. So let's see, SVDI of, maybe let's use P this time, and we're going to do divide by 7.3. So we'll do P divided by 7.3. And then for the inverse SVDI function, it'll be multiply by 7.3. And the way you can show multiplication with a variable is just put the number right next to the variable. Alright, this one, there's no inverse function that exists, and I think it would take me longer to write the function out mathematically, because look what I would have to do. I would have to say h of x equals, how am I going to do this? There could be 1 digit, or 2, or 3, or 4, or 5. It's just not possible for me to write out all of the answers. So I think it's probably a bad idea to even try to write this function using math symbols. It's just shorter to write a description of it like this. And mathematicians try to use the shortest way to describe things. Alright, so next the SQRT function. So SQRT function, we'll go back to x this time. And it says to take the square root of the input number. So here's the math symbol that says take the square root. Alright, for the inverse square root, for the inverse SQRT function, put a little -1 up there. And it says that the inverse function is supposed to square. So all I have to do for that is just take the number and square it. I could have also written that like this. I could have written the number times itself. But the way mathematicians usually write that is with an exponent. Alright, Pelio function. First thing to do is add 2, then square. Now I can't just put an exponent right here or else only the 2 would get squared, and I want this whole thing to get squared, and then subtract 3. Now for the inverse Pelio function, I'm going to first add 3. Add 3. Then I'm going to take the square root of that. And then I'm going to subtract 2. Alright, for the y function, and then I'll put x into the y function. And let's see what happens. First thing is I need to add 7, so I'll do x plus 7. Then it looks like I need to multiply that by 4, so I'll use parentheses and I'll multiply that by 4. Then I'll subtract 10. And then it says to divide by 2, so that whole number that I got by adding 7 and then multiplying by 4 and then subtracting 10, I need to divide that whole number by 2. So put the division bar underneath the whole thing and divide by 2. Alright, now for the inverse y function, if you put an x into the inverse y function, the first thing is to multiply by 2. So x times 2, usually we write that as 2x. Now add 10, so plus 10. Next thing is to divide by 4, so I'll take that right there and divide by 4. And then whatever I get from that, I'm going to subtract 7. Alright, the Scheider function, so starting out, Scheider of, maybe let's do another letter now, M. So to double something means to multiply by 2, so I'll do 2m, then divide by 3, so I'll take that and divide by 3, then I'll add 4, and then I'll divide by 2. So I need to take this whole thing and divide it by 2. So I'll put the bar under that whole thing and divide by 2. It's getting a little complicated with the multiple divisions there, but you should be able to understand what it means and the order to do it in. Alright, now for the inverse Scheider. first thing is to multiply by 2. So I'll do 2 times the variable, then subtract 4, then multiply by 3, and then divide by 2. Alright, next thing, XUP function. So XUP, we'll choose an X. Actually, maybe I should do a different letter since that might get confusing since there's an X in the name of the function. Maybe I'll use C. So first thing I'm supposed to do is add 3. So C plus 3. Then it says to double that, which means multiply by 2. So that whole number right there, I'm going to multiply it by 2. Then it says to subtract 4. Then it says to divide by 2. So the whole thing gets divided by 2. And then it says to add 3. So plus 3. Alright, next for the inverse XUP function, I'm going to first subtract 3. C minus 3. And then multiply by 2, then add 4, now divide by 2, so that whole thing's going to be divided by 2, and then subtract 3. Alright, got some big ones this time. So love function, if we put an x into that, we're going to get multiply by 10. So 10 times x, then subtract 7, then divide by 3, then add 11, and we're going to multiply that whole thing by 4, and we're going to subtract 1, and then we're going to double that whole thing, so we're going to multiply that whole thing by 2. I'm running out of room. That looks a little weird. Should have stayed kind of on the same line. Next one, for the inverse love function. Alright, first thing we're going to do is divide by 2. Then add 1. Then we're going to divide by 4. Then we're going to subtract 11. Then we're going to take that whole thing and we're going to multiply by 3. Then we're going to add 7. Then we're going to take that whole thing there and divide by 10. Got a little squish down there at the bottom.